You're listening to The Weather Junkies.
Oh boy. A large wedge tornado coming up into Tuscaloosa. A winter storm warning is in effect for our area.
So we can expect at least another 2 to 4 inches overnight. Then that says
the National Weather Service in Huntsville has issued a tornado warning for northwestern Madison.
14 to 22 inches of snow!
Good Thursday evening. Thank you for joining us on the Weather Junkies. I'm Tyler Jankowski here in Connecticut alongside Dakota Smith, joining the show from Colorado. Dakota.
Hey, Tyler. Hey, everyone. Thanks for joining us. Another beautiful day in Colorado. I tweeted today that this is some of the best few weeks of weather I've ever experienced. I haven't lived in Southern California, so that would probably take the cake there. But from where I've lived, this is unbelievable. You had, it gets into the mid-upper 60s every day, super sunny. Not much to complain about. People want the snow, especially the some of the mountains and resorts up here are starting late. But I know it's going to come eventually, and I'm holding on to this weather right now while I can. Tyler, how's the weather on the East Coast?
I'm ready to believe the saying that says where it doesn't rain, it doesn't want to rain. The other day, yesterday, we were a few days before yesterday, we were forecasting about 1/4 of an inch of rain, and the main reporting site, Bradley International, got 1/100th of an inch, 0.01 out of the whole event. And it's going to be dry into early next week. So we've done some calculations into the future, and on Tuesday of next week, the rainfall deficit since the beginning of last year will surpass 20 inches. So the deficit will be over 20 inches starting next week. And the drought monitor that came out today does not change our categorization by any percentage point, but most of the state's still in a severe drought. Part of the state, a much smaller part of the state, is in a moderate drought. So the projection has been for quite some time that the drought's going to get worse here, at least in the short to medium range, and that's happening.
Yeah, never a good sign. And similar in Southeast, they're in a pretty big drought right now as well. We're actually in a drought out here. I think it's whatever the second tier on the drought monitor is. So not that bad yet, but we'll see what happens in the next few weeks and months. Tonight, we're lucky to be joined by Robert Simmon. He worked for NASA Goddard for nearly 20 years as a data and information visualizer. He got his master's in material science, which we're going to talk to him about how he got from there to where he is now. And speaking of which, he's at Planet Labs now, or also known as just Planet, as the Senior Data Visualization Engineer over in San Francisco. Robert, thanks for joining us tonight.
Hey, you're welcome.
So how's the weather in San Francisco? You mentioned it was pretty warm for this time of the year.
Yeah, I think it's a bit warmer than normal. I've only been here. This will only be my 3rd fall here, so I don't really have a great point of reference, but mid-70s, sunny, and sunny over almost all of San Francisco, not just Soma and the other areas or East Bay that are normally sunny. And then this morning was actually walking my dogs in the East Bay Hills, and it was super windy, and I could smell wood smoke, which is always a little bit discomforting considering the history of fires in that area. But I don't think anything happened. Yeah, that's not good. I think every other day I see some smoke out here, and I'm like, oh, there's another brush fire or something. So we'll dive into what Robert does and what he's done in the past in a bit. But right now, let's get at some of the things that were trending in the Weatherverse this week. First up, I have a tweet from Greg Dutra. He's a on-air meteorologist, and he tweeted, doing weather with a beard and a beer in hand. Is there any other place better to work than Fox 31? This is the dream, Tyler, I think. I know you're not the biggest beer guy.
I can't stand beer. I prefer straight liquor. All right, that's enough of that.
Yeah, maybe a cocktail in hand.
Yeah, I would say that being able to give a talk or otherwise a high pressure situation with a drink in hand can be a nice relaxing aid.
Yeah.
Wonder what the
completely
backstory is here.
Yeah, I actually don't know. I didn't click the link, or no, there is no link. I didn't look further. He's a meteorologist out here in Colorado though, so he's on one of my channels. Tyler, you want to talk about the drought in this next tweet here?
Yeah, the next tweet comes from Drew Tuma. He's a meteorologist in the Bay Area at ABC 7 News, but he's tweeting about the Southeast where the new drought monitor came out today, and exceptional drought conditions are now taking control over parts of the Southeast. North and west of Atlanta, Georgia, is where the drought is at its worst. And according to Drew, he says some cities have not seen rainfall in more than a month. So this drought definitely starting to make some national headlines. I really hadn't known much about it before the last couple of days, but I remember just a few years ago there was a bad drought down there, wasn't there?
Yeah, there was. I think it was one of the worst droughts they've seen in recorded history. I saw James Spann say today that they're expected to get some rain in the next few days, so that's always good. But yeah, not a great situation down there, and there's drought across a large portion of the country right now. It's a little concerning, I'd say. But we'll move on to the next tweet here. Kind of a funny one. This is from Angela Fritz. She's over at the Capital Weather Gang, one of the writers over there. And her tweet says, "Whoops," and it has a picture of a tweet from the National Weather Service Rapid City at the real Donald Trump, our president-elect. And it says, "Congratulations, Mr. Trump. We, the average American, are praying that you can bring this country back from darkness." If this was a tweet to Hillary or a tweet to Donald or any other politician, it's never good to see that kind of interaction on social media. So someone just made a mistake, I'm assuming, and thought they were tweeting from their personal account. And
do you think anything changes when you go from campaign to elect, or should you just never tweet that as a government account?
You should never tweet that as a government account, or honestly, even from a corporate account.
Yeah, I think I don't know. I think if it was like something along the lines of like being playful with the president, it's different. But it implied that the past president was not great because we're in darkness, and so it got political. If you didn't keep it, if you didn't make it political, I think that'd be fine.
So if you just said "Congratulations, President-elect Trump" from a government account, that would be fine.
I mean,
I'm not quite sure that that's actually okay, having tweeted from a government account for a number of years. It probably varies by agency, but I think it's always best to err on the side of caution.
I only ask because I wonder at what point do you have to support the person you're working for?
Yeah, that's true. It's probably not just worth it, though. I mean, I don't know. I think it's not worth it, but I honestly think this wouldn't have been a big deal if they didn't make it political by the last bit saying that we're in darkness.
This definitely falls in our bin of NWS tweets that were not meant to be sent out. We can definitely gauge that that's what happened here.
Yeah, it happens every now and then. I hope they didn't lose their job for doing this, but
it's probably not. It's a stern warning type of thing.
Right, exactly. We'll move on to our next tweet here. This is from Jeff Frame. You can follow him at Vortex Jeff. He's a cheery. He storm chases. He's a great follow. Give him a follow if you want. His tweet says, "Lee Orff showing eye candy at SLS 16, which is the Severe Local Storms Conference provided by the American Meteorological Society." And the tweet has an image here of some, I think, pretty beautiful visualization of, I'm pretty sure it's Cloud Model 1. I wasn't at the talk, so I'm not 100% sure, but normally when you see these visualizations It's Cloud Model 1 showing a supercell. And right here it's showing tornado genesis. And you can see kind of like these vorticity lines being advected upward and forming a tornado. And he has some, I know he has some movies of this. So it's just spectacular to watch. And the science behind it is also pretty important too. But Robert, I was curious what you thought of this visual here.
I mean, I definitely agree that it's some wonderful eye candy. My taste in data visualization tends to run on the a little bit more diagrammatic or austere. And this has a lot of detail. It's probably a bit different in motion as well, which can be a super powerful tool, but can also get confusing pretty quick. But I think it's probably it's a very good slide to draw people's attention in, as long as you have the person there to explain all the elements, because looking at it by itself without being in the context of the talk and not being a meteorologist, which is admittedly probably not the target audience, I really can't get that much out of it.
I gotcha. Yeah, I think it does work well in that frame, that mindset. Most of the people watching this talk are like atmospheric scientists that are researching mesoscale meteorology. So I kind of agree with you there. Let's see, our final tweet here, some more imagery, and I'm sure you can speak to this one a little bit more. This tweet's from Zach Labe. You can follow him at zlabe. We have a few of his tweets on our show every now and then. And his tweet says, some pretty satellite imagery to distract, assuming from the election. 980 millibar extratropical low north of Japan today. And it's a nice visible loop of an extratropical storm. And you can see a ton of low-level stratocumulus off the continent there. And then at the end, you get some night, some lights there at night. And I'm pretty sure that you had a part in, at some point, making this visual, Robert. Tyler, what do you think of this?
I love it. I remember watching the wall at Penn State where you could see the night lights and the satellite with it. I love the filter of where it's day and night out. It's pretty cool. It makes it easy to look at and figure out. And speaking of the night lights specifically, in the graphic system that we use, we actually can zoom in quite far to the state level and get a crisp depiction of where the night lights are. And you may have seen some of the graphics I've tweeted over the last year or two. And I don't know how they do it, but they actually have a way to zoom into individual towns and still have the lights be crisp without getting blurry. And it's unrealistic if you look close enough, but they did a really nice job of making it so you can zoom in and still have the nice night light effect.
Yeah, so I apologize, but I'm having a couple connection issues. But I'm actually pretty familiar with the night lights data sets that are out there. I did one of the earliest renditions in 2000 using a sensor called DMSLP. And then this is from VIIRS, which we did as part of the NASA Black Marble project back in 2012. And yeah, so that data set's actually at 1 kilometer per pixel.
Oh, okay. So you can zoom in quite far.
You can zoom in quite far. And then it's also possible if they're going in deeper than that they're actually sort of taking some other data set like city streets or something like that, and then adding some color in to make it basically look like it's a lit up town at night. Yeah, they add the lights onto 3D buildings. It's pretty neat. Yeah, so that's probably built on a model of the city and then some other data set laid in on top of that.
That's really cool. I didn't know you were using some of that on air. So that'll do it for our Trending in the Weatherverse tonight. And let's get on to our main segment here with Robert. So you spent a number of years at NASA. You're at Planet Labs now, but you have a master's in material science. You were out here at Colorado State just last week, so I kind of know your path, and it's remarkable, I think. So I just wonder if you could share that with our audience.
Yeah, I definitely wouldn't call it a straightforward one or one that I planned in any way. But basically was in an undergraduate program in material science and just was in a time when it didn't seem like there was that many job opportunities, and the most obvious path was grad school. So ended up signing up for a graduate program at Carnegie Mellon, and just really, it didn't get along with me. And there was a number of reasons for that. One of which was I have tended to be attracted to interdisciplinary fields. So like the intersection of engineering and science for material science, but was also doing electronic music and science and technology studies. So basically the intersection between science and engineering and society to go along with my engineering classes at RPI. And then I got to CMU, and it was very much like, you will do nothing but materials science 6 days a week, 10 to 12 hours a day, and a very focused program that was also very much a 5th year of undergrad. And 16 years of schooling, and you get kind of tired of the drag of going to classes every single day, and really no research whatsoever in the first year. And ended up just kind of getting a master's degree as, sort of a going away prize and going home. And without really having a clear idea of what I was going to do, friends of mine from high school who were already working at the NASA facility in Maryland called NASA Goddard, they had another colleague who needed some support doing a CD-ROM, which sort of dates when this was, to expose some of the NASA ozone data in a way that made sense to the general public. So I was actually sort of brought on to do visual science communication in a way that I had never really been expecting or never planned for. And just because I had that interdisciplinary background where I had, along with the computer music, I had done some computer graphics, and again, sort of like the intersection of science and society, had an interest in how to communicate this type of things to people who weren't specialists. And just basically took it from there.
And so now you're at Planet Labs in San Francisco. So I'm curious, what kind of drives you to make these visually appealing and stunning images? You alluded it was kind of to get a point across to people who don't know the data that well. Is there anything else there that kind of drives you to do what you do?
Yeah, I mean, some of it is definitely like I am excited by telling stories about data and stories about our Earth. It's an endlessly fascinating planet, and it's an endlessly changing planet. So even, at a small scale, you'll get different weather day to day. At a bigger scale, you'll get seasonal changes. So obviously, in a temperate climate, you go from, green fields in the summer, colorful fall leaves to snowy winters, and then a melting of the snow and a green up, and you kind of repeat the cycle, but it's never the same twice. And then you add on top of the fact that we've got 7 continents, a dozen or so biomes that all behave differently in different terrains, and then add on top of that, the human influence, and both in the good and the bad ways that we are affecting the planet. And that means that there's just sort of this, it's essentially an endless playground of interesting imagery to work with. And then I really enjoy both tying some of the conventional, color satellite imagery or false color satellite imagery together with other types of data sets like temperature or vegetation or population density to basically show the relationships between these different phenomena. And another really appealing part of my job is seeing things that no one has ever seen before, because we're collecting this huge, tremendous amount of data, most of which is either never looked at all or looked at only by machines. And so being, sort of combing through an archive or combing through a real-time stream of data, you're literally seeing things that nobody else has ever seen. And to be able to sort of find the interesting parts of that and share it with other people who also find it fascinating, it's a really enjoyable and rewarding job.
I can relate to that last part there, using some of the OCO2 data. So I'm curious, you have a number of clients, or Planet has a number of clients. I was wondering if you could give us like an example or two, because I know it ranges a kind of a broad spectrum of who you're helping and who you're making these images for.
Sure. So we're still very much a startup. So we are sort of more in an exploratory realm of finding clients who can make use of our data and really making sure that what we're producing is useful for them. And they range from like an individual research group in Norway looking at glaciers who used our data sets to both discover the location and sort of some of the specifics of a glacier that collapsed in Tibet in a way that was almost unprecedented, and left this huge ice field, and basically where overnight in a matter of minutes, an entire glacier just slid down a mountainside and into a lake. And they were actually able to use our data to predict another glacier right next door, actually in the next valley, that ended up doing the exact same thing a month and a half or so later. It turned out that they actually gave the warning to the Chinese government a couple hours, within a couple hours of the collapse actually happening, which was too late for any action to be taken. But fortunately, there was nobody in the area for the second one, whereas unfortunately, for the first one, it actually did kill a number of herders in this very remote area of Tibet.
So I'm looking. Oh, continue.
Go for it.
I'm looking at the website now for the place where you work, and the high resolution imagery is fascinating to me. I would think that you maybe do some work for security projects and security agencies as well.
We do, and we actually signed a pretty significant deal with the United States' National Geospatial Intelligence Agency, and where they are responsible for providing the American government, not just the Department of Defense, with maps and other what is called geospatial information. So, maps and anything that's tied to a location on the surface of the planet. So I think it's pretty easy to imagine some of the things that they're interested in. The scale of our imagery is in a lot of ways most useful for setting context and for understanding things at sort of a more macroscopic level. You're not using it to plan individual operations, but it seems to be, although they're not completely at liberty to say exactly what they do with the data.
I have had some experience with Nearmap. I don't know if you've ever heard of Nearmap, but I've used some high resolution images to create security maps for a large sporting event. But can you talk a little bit about how your satellites work and how you obtain these images?
Sure. So we use what's called the CubeSat form factor, which is it's a standardized type of small satellite. And the cube part is that it's based on a 10 by 10 by 10 centimeter unit. And ours are actually 3U sats, which means that it's 3 of those dimensions stacked on top of each other. And that gives us room for a telescope. As a rough estimate, about half of the volume is a telescope. Also need batteries, attitude control system. We have solar panels that are sort of deployed. You can call them wings, although obviously they're not because they're operating in a vacuum. A camera and a radio. And so we have the camera is the combination of the telescope and a pretty conventional CCD, where we actually are taking frames of data instead of continuously collecting data like a more conventional system like Landsat would do. And in each of those frames, we're about 22 by 15 kilometers at 4-ish meters per pixel. And I'm being a little bit imprecise in the resolution because there's different ways of measuring resolution. So that 4 meter number is what's called the ground sampling distance. So that's the space between the pixels which is sort of your very best case. And that's limited by the size of the aperture, which is the size of the satellite, and it's limited by the altitude. And so really what we're bringing to the table is global coverage every day at that resolution. And so you can get very high resolution coverage, either from another commercial satellite, and there's a number of different vendors, or from an aircraft or from a drone, but you're not likely to be able to get those every day, or even every week or every month. And then you can go to some of the government satellites, Landsat in particular, which does 30 meters per pixel in different wavelengths, so 30 meters per pixel color every 2 weeks. And then things like MODIS, where you're doing 1 kilometer per pixel every day. And we are actually, almost 2 full orders of magnitude, or more than 2 full orders of magnitude higher resolution than MODIS is. So it really opens up this qualitative new way of looking at the Earth.
So your satellite or satellites take a picture of the whole Earth. You don't have to tell it where you want a picture of. That's pretty impressive.
Well, each picture is of a very small chunk of the Earth. But basically, whenever we're over land, we are collecting data. So at this point, about 50 satellites and eventually more like 150 satellites, we'll be able to have enough coverage with the satellites spaced out very carefully to do a near global land surface cloud-free image of the planet every day.
Wow. Approximately how high above the Earth are they?
It varies a little bit. We had sort of a several series of what we call flocks that were launched from the ISS, and those start at about 400 kilometers, depending on exactly how high the ISS is at any given time. And right now we've started to put sort of more our operational instead of experimental flocks into sun synchronous orbit. And I believe the current one is right at 500. It might be give or take 10 or 20.
So I'm curious about some of the examples that you were talking about earlier. Do you ever use some of the imagers to look at before and after weather events?
Oh, sure. So let's see, very recently we did flooding from Hurricane Matthew, both in Haiti and in North Carolina. Wow. I just this morning, it's something that we haven't made public yet, was looking at hail damage at some farms in Uruguay earlier this year. We have certainly seen tornado tracks, but as you can imagine, the atmosphere in the immediate aftermath of a weather event is often partially cloudy. So it's not really a great image to share with the public, even though we have seen that type of phenomenon. We've done snowstorms. You can actually see a pair of images that I really like, where you can see somebody plowing the runway at National Airport after a big snowstorm. Again, I think that was earlier this year.
Wow, I'm super jealous of the fact that you get to look at all those before after weather images, because whenever they do some of those plane flybys, like they did one for Matthew along the southeast coast, I spend a few hours looking through those to find different types of impacts. Like I found one where there was a new inlet in like northern Florida. Yeah, and then that was really cool to look at.
Yeah, so one of the real advantages that we bring to that type of disaster analysis is, the aerial imagery that's collected immediately after a disaster is almost certainly going to be higher resolution. But what we bring is we'll actually have had a picture from immediately before a storm. So you can have a very up-to-date picture of what conditions were like immediately beforehand. And, in the industrialized nations like the US, that's not necessarily such a big deal. But in a lot of cases in developing nations, you'll actually have a situation where there's infrastructure that's appeared since the last time anybody drew a map. And there might have been a landslide that preceded a typhoon, and being able to sort out, what's a new landslide versus an old landslide can be a very important thing when it comes to responding correctly to a disaster.
That's a good point, because whenever they do the before after, normally the images are a month or so old, and if there was some sort of looking at it from a different perspective, if there was like a different weather event or different types of flooding that happened the week before or something, yeah, you wouldn't be able to pick that out compared to what they're actually trying to look at.
Yeah, it's really a new way of looking at things.
So I wanted to shift gears here for a second and talk about HCl, which stands for hue chroma luminescence. It's a product that scientists can use to create color palettes to visualize their data. Robert actually pointed me in that direction, and I'm already going to use it for a project that I have to submit next week because I am all about it. And you can go onto their website, hclwizard.org, and it's super easy to use. You just go to like how to use it on their site, and you can download a bunch of different color palettes that you like. You can make them online and then download them in R or Python or Grads. I think there was another one you could download it in. So it's really cool. And I kind of the overview that I got, and from what I was understanding, is that it was a color model that creates these schemes based on hue, the color, the chroma with the intensity of the color, and then the brightness and darkness of the color, compared to the rainbow spectrum that a lot of people used and still use to visualize their data. So, Robert, I was wondering, why is HCl so much better than the rainbow spectrum?
Right. So HCl is actually what's called a color model. And what that means is on a computer screen, you have red, green, and blue pixels, and you make a combination of those three colors to build out a full, in most cases, 24 million color gamut of colors that you can possibly reproduce. And the computer is looking at things in terms of these three values. And in a way, your retina is looking at it in terms of red, green, and blue. Although a scientist of the eye would actually refer to the short, medium, and long wavelength cones in your eyes, because they actually have a quite broad distribution of wavelengths that they're susceptible to and will respond to. But essentially, as soon as the retina receives the light and turns that into a series of electrical and chemical impulses, our brains are really looking at color in terms of those other three components. So it's a three-dimensional color system, just like RGB is, but instead of having each of these discrete colors, it's split into hue, which again is sort of what we colloquially would call a color. So red, green, and blue are hues. Chroma, which is also known as saturation. So that's the intensity of a color. So blood red versus a pink. So a highly saturated color is blood red, and a pink all the way to gray is lower and lower saturation. And then luminance or brightness is pretty self-evident, where it just goes from white to black. So the very brightest things are always white and the very darkest things are always black because they can't have any color. And so because that's sort of how our brains interpret color, it turns out that using a model that's based on those three components gives you color palettes that work how we see, instead of color palettes based on code and how computers and TV screens represent color. And that allows you to build palettes that are what are called perceptually accurate. So they sort of minimize the distortions that are always going to be inherent in displaying a data set. And the rainbow palette, in contrast, is just basically based, although there are variants, on these three red, green, blue color components, which means it's easy to code for. And a lot of software, especially older software, has a rainbow variant as its default. But it introduces a lot of artifacts in the representation between the color and the data. And one really obvious one is you get these bands in the color where between yellow and green, you get a very sharp transition. but there's a very broad range of greens. And so that means that combined with our visual system's propensity to find edges in things, that we tend to look at data displayed with a rainbow color palette and find segments and sort of break it into these chunks that may not be physically meaningful. And so despite the fact that they're ubiquitous, I really think that a rainbow palette is a harmful way to do data visualization.
So this alternative way to display weather information you like better because it's smoother and it doesn't have these artifacts in how things look.
It's not necessarily that it's smooth, it's more that it's uniform. So an equal change in color is, a change in data is represented by a proportional change in color. So the difference between 10 and 11 looks like this difference between 100 and 101. And with the rainbow palette, you might be able to see 10 and 11 with a very sharp boundary, and then the difference between 101 is almost completely hidden. And so it just distorts the underlying data. One analogy would be taking the y-axis on a plot and then changing the interval between the tick marks, sort of quasi-randomly.
Yeah, I see what you mean. Yeah, well, it seems like the Weather Service does a lot of the RGB stuff.
Yeah, and I think that's partially because the Weather Service has been doing the exact same data visualizations for a very long time, and there's reasons for that. To have a standardized product that everybody is trained on. And it is quite possible that these were developed in an era when not everybody had a 24-bit color screen. So being able to limit that down to an 8-bit palette, or sometimes even fewer, was very important. Not that they still couldn't have done it better, but that was also, it was before some of this color theory, which has a very long history in cartography, sort of made it into the remote sensing community and what we now know as the data visualization community. So people doing visualization on computers were pretty much separate from people drawing maps by hand.
I think one benefit of the way the Weather Service does things, for example, on model outputs, is as forecasters, oftentimes we look for the half-inch line, the 1-inch line of QPF, maybe 1.5, and it gives us a sense for how big or how strong a storm might be. And if you use a scale that makes it harder to see those delineations, it might be tougher to get a quick sense for what's going on.
Yeah, I have at least two responses to that. One is you can actually play some really interesting tricks if you have very solid control over your color space. So you could, for example, make a scale that is perceptually uniform in lightness, but change the hue when you pass a threshold.
Okay.
And so you would go from, say, a pale blue to a slightly darker, slightly richer blue, and then go from a matching green, that's that slightly richer green, to a yet darker, more intense green, and then to red. And so that would segment out the color palette. So you'd have these different regimes of weak, medium, strong, but still keep that overall pattern. So you didn't have these really rough continuities, and especially introduce sort of unintentional continuities. And so there's also some subtlety in, if you have a continuous palette that's using, more than, say, 15 colors or 20 colors, where the gradations between the different colors sort of smooths into a ramp instead of being discrete blocks. And so you can play with that a little bit. The other thing that you can do is actually overlay other information. So you could actually put an ISO line that represented these different categories. And so I think that if you think about your color and take some of these ideas from the data visualization and cartographic communities, and again, cartographers have been doing this for well over 100 years. And as a science of displaying things on a map, I believe we could get much easier to read data viz.
So I can send it your way, but Robert sent me a article in AMS and BAMS where they look at an SPC precipitation outlook plot. Or actually, it's not an outlook; it's a reanalysis of Sandy, and then they show what the SPC put out, or sorry, not SPC, the Weather Prediction Center (WPC), and then they show two versions of what they would put out, or what they recommend, and in one of them, it's very smooth kind of transition between heavy and light precip, but then the other one, it's still a smooth transition, but they have those kind of lines that you can still pick out as the 1-inch line or the 2-inch line. So give that a look if you have.
I definitely will.
So kind of on a similar topic here, I share with you a kind of comparison of National Weather Service watches and warnings, comparing to private sector, comparing to on-air meteorologists, and comparing the color of those watches and warnings. And I guess from your perspective, how important is keeping a consistent color and presentation scheme when it comes to presenting data?
That's a really good question that I probably don't have an authoritative answer for, because it relies on so many variables. So there's going to be a difference based on who your audience is. So if me as a meteorologist or a scientist were communicating to other scientists within my community, I think that there's a different set of standards that apply than if I'm trying to show something to what is called an interested public. So somebody who's like a weather enthusiast or a storm chaser who might be familiar with your community, but not formally educated in it. And then versus the general public, which would be the type of people who need to respond to and interpret an actual alert of an incoming weather event that they need to take action to protect themselves from. And so having consistency so that no matter what TV station I'm watching or which government feed or private company I'm looking at, that I know that I need to take shelter right now because there is a tornado that's been spotted that's barreling towards my town. I think that consistently really would help. And I think also consistency, like within a single paper or a single presentation, is also super important, so that you don't confuse people who are going to look at a bunch of similar plots and sort of assume that there's consistency there. So there's really sort of a number of different ways to address this question. But I'm looking at these examples that you had given in a blog post you wrote called The Watch and Warning Rainbow back in August, where you have colors that are literally all over the map, from the richest, darkest reds to even blue or green, which for most people are interpreted as sort of calming colors, versus the red, which is very much an alarming color. And so, having a consistent way to communicate means that people who are unfamiliar with something and maybe only vaguely remember it, hopefully have a better chance of responding to something.
Yeah, it's definitely a problem that the community is trying to figure out. One example that they can learn from is, I don't know the year or when it happened, but at one point the Republican and Democratic parties were represented by different colors on election maps. And at some point they all got together and said, all right, Republicans are red, Democrats are blue, and that's what we're doing. And now it's just kind of common for everyone to know that that's what it is when they're looking at a map like that. Or so hopefully we can do something like that. It's a little more complicated when you have a lot of different watches and warnings and so many different outlets. But I'm hopeful that we can improve and make it a little better.
There's a fascinating history behind the red state, blue state, which is a completely different rabbit hole to jump down, of where it's actually purple because most communities, although that's changing, in the past, most communities had a mix of voters. And so to say that, oh, this is purely red versus this is very purely blue, even though that's how electoral votes are distributed, gave this very misleading, very divided view of things based on, the state administrative level. And so there's a New York Times article that I think came out last week, which I can track down the URL, which actually went through the history of the New York Times visualizing elections. And it has some really fascinating examples of how they have done it in the past and how they've modified that to take advantage of modern research and do sort of the best job possible with current understanding of making an accurate estimate of who's voting for which candidate in which parts of the country, and sort of how much influence even that each of those parts of the country are having on the outcome of the election. Because Wyoming is a giant state with 3 electoral votes, and Massachusetts is a much smaller state with many more electoral votes. And if you display them both with the exact same color, it's sort of misrepresenting the weight of that. So, and as I said, it's a super deep rabbit hole, one that despite the very narrow and very recent election, I'm actually not incredibly well versed in, but there has been some really good commentary from some of the previous elections, and then sort of in the run up to this one.
Yeah, I've seen some very cool things come out recently, graphics of regarding the election, and it's amazing how far things have come to display this information. I looked at the New York Times website, and I'm not sure which scale they use, but they definitely had shades of reds and blue that they were using on their forecasts and on their maps.
Yeah, it's a basically saturated colors at the extremes that blends towards a less saturated one of red and blue at the extremes, and then a less saturated purple in the middle, I believe. And so that really gives you an idea of not only which areas went for a particular candidate, but how strong the support was and how many people live there. Because it's very easy when doing certain types of maps to basically just get a population map. And that's a different way of being misleading.
Each week at the end of the episode, we ask our guest for advice for someone that may be considering studying, we'll say science this time around. Usually it's a meteorology question, but we'll say science. For someone considering studying science or already in the process of doing so in college, what would your advice be to them as they move forward?
I think we lost him. Oh, he's back.
He's back. We'll have to see if he got the question.
Wait, Tyler, I think you're gonna have to ask it again.
Can you hear me?
Yes.
Perfect. So we end each episode with an advice question, and usually it's meteorology driven, but for this instance, we'll just say science. What type of advice would you give to someone that's considering studying science or already in the process of doing so in college? What advice would you have for them?
I would say a couple things. One is to make sure that you're not so focused on your particular discipline that you don't learn about other things and take advantage of the other opportunities at your university or college. I had mentioned earlier that it was very important to me that I was exposed to some of these other aspects of things that intersected with science, but were not themselves sciences. And that really helped me going forward, in large part because I found it very easy to teach myself design. Granted, I had several years to do it, but I could never have taught myself the science to understand what my colleagues were talking about and what I was then trying to communicate without having a formal degree. So just the way my brain worked, learning the science through a degreed program and then sort of the other stuff ancillary to that worked out very well. I think you can do the reverse of getting a design degree, but taking science courses and learning sort of the scientific worldview. But don't limit yourself to boxing yourself into a very narrow spot. And similar to that, keep an open mind. Like I essentially had been interested in issues about the environment and human interaction with the rest of our ecosystem and computer graphics, as a student, even going back into high school, but had never imagined that it was something that I would ever get paid to do. And yet, sort of through a quirk of fate, I ended up doing that as my career. And never ever earning a penny outside of a stipend at doing real research or work in the material science degrees that I have.
That's great advice, especially for meteorologists. It's becoming a more and more interdisciplinary field where you need different types of backgrounds to get the job that you want. Great advice, Robert, and thanks for joining us tonight.
You're welcome.
And if you're not only following us on Twitter, you can follow us at the WX Junkies. We're also on Facebook. You can listen to this podcast on SoundCloud, YouTube, iTunes. If you're over on iTunes, give us a rating or review, please. We really appreciate it. Tyler, who's on next week?
Next week we have Sean Milrad
I
on.
think it's Millard. I think.
He's an assistant professor of meteorology at Embry-Riddle University at the Daytona Beach campus, and we're excited to have him on. He has his PhD from McGill University in atmospheric and oceanic science. So that'll be next Thursday live at 8 o'clock. We hope you'll join us then. But that'll do it for this evening's episode of The Weather Junkie. For The Weather Junkies, well, there's more than one of us. For Robert, Dakota, and myself, thank you for listening, and we'll see you right back here next week.
Good night.